So in today's video, we're going to be going over balancing redox equations using the half reaction method, which is just one of the few ways to balance redox equations, but I find this method to be the most straightforward and easy to understand. So let's take a look at this first question here. It's asking us to balance the reaction in an acid solution. So for redox reactions, they're going to happen in either an acid or basic solution, which will be told in the question, and according to which there are slight differences in how you solve each equation. So I've listed all the steps up here, and it's very important that you follow these steps in order and properly. So the first step is to write two separate equations for oxidation and reduction half reactions. So hopefully you can see that this hydrogen peroxide will match with the O2, and then the dichromate will match with the chromium ion. So let's write out these two half reactions. I'm just going to write it separately. So it's going to be hydrogen peroxide and then put an arrow and then O2 on the other side, and then dichromate, arrow, and then the chromium ion. So first step is done. The second step, 2a, says balance all the elements except hydrogen and oxygen. So for the equation on the left, we don't have any elements other than hydrogen and oxygen, so we're going to skip that step. That step is done for now. For the right reaction, the reaction on the right side, we have two chromiums here, but only one chromium here. So what we need to do is add the coefficient of 2 on this side. So 2a, done. Now 2b, balance the oxygen by adding H2O. So as you can see on this side, we have two oxygen atoms on both sides, so that step is also done for now. On our right side reaction, we have 7 oxygens here and no oxygens on the right side. So we're going to add 7 waters, so 7 H2O. So now you can see that our oxygens are balanced. 2C says balance hydrogen by adding H+. Now on the right side, on the left side, we have 2 hydrogen atoms here and none on the right side. So what I'm going to do is add 2 H+ ions. Just like that. So we have the hydrogens balanced, and we're going to do the same on the right side. So here I have 14 hydrogen atoms. It's very important not to forget about this coefficient here. That's a common mistake that people make. So I actually have to add 14 hydrogen ions. Okay, now 2D is balance the charges using electrons. So what I'm going to do here is we're going to pay attention to this charge here. So you want to think of this as a whole. So all of the charges on the reactant side and all of the charges on the product side are going to add together, and then you want to balance it on both sides. So on my left side, the hydrogen peroxide, we have a charge of 0, and on this side we have a +1 charge. So what do we need to do to balance it? Well, we need to add an electron to the product side. Oh, sorry, this is actually 2. I made a common mistake there. You actually have to multiply this coefficient of 2. So it's a +2 charge, and we need to add 2 electrons to neutralize. Now for the right equation, over here, this is 14 plus. We have 2 minus over here. So altogether, this is going to be 12 plus. And then this water is just 0, and here we have 6 plus charge. And don't forget, we have to multiply the coefficient. So to balance this, we have 12 on this side and 6 on that side. So what we can do is add 6 electrons to this side to make the net charge 6 plus. So that's exactly what I'm going to do. So 14H plus 6 electrons, just like this. And then write our equation like so. So we're done with this step. Now, step 3 says, if necessary, deduce the least common multiple and multiply each coefficient to balance the number of electrons transferred. So what we're looking at here is this and this. Well, our least common multiple is just going to be 6. So how do we balance it and make sure that these two electrons transferred are equal? Well, we need to multiply this entire equation by 3. So all we're doing is adding a coefficient of 3 at the front. So this is going to be 6H plus 6 electrons. So question 3 is done. Question part 4. Add the two half reactions together, canceling out identical species. So what you'll notice here is the 6 electrons are going to cancel out. This H plus is gone, and then this coefficient is going to be 14 minus 6, which is 8. And then that should be about it, so we should add it all together now. And keep in mind, when you're canceling out species like this, they need to be on opposite sides of the equation in order to cancel out. If they're on the same side, you just add them together. So this is going to be hydrogen peroxide plus the dichromate plus 8 hydrogen ions. And then on this side, 3O2 plus 2Cr3 plus 7H2O. So you can move on to the next step. So step 5 doesn't apply to us because it's specifying in a basic solution, so we can skip this step. And now just check step 6 to see if all the elements and charges are balanced. So we have 14 hydrogens. This is 8 and then 6, so 6 plus 8 together makes 14. For our oxygens, we have 2 and 7 making 9. Oh, sorry, this is actually 6 because we have to multiply the coefficient. So 6 plus 8, which is 14. Here we have 6 and 7. Oh, sorry, not this. So this is 6 plus 7, so 13. And then here we also have 6 plus 7. So 13. The chromiums, this is 2. This is also 2. So our elements are balanced. Now let's check the charges. Well, here I have 2 minus and plus 1, making a net charge of minus 1. And then on this side, we have, okay, I made another mistake. So, okay, this is 2 minus. I have to multiply the 8. So it's plus 8 minus 2, which is a minus 6 charge. And then here we have a 3 plus, but then we have to multiply by 2, which is also plus 6. So the charges cancel out, and this is our final equation. So now let's move on to the next one, which is a bit different. This is in a basic solution. So we're going to follow all the steps we did until up to step 5, where we have an additional step before we check the balancing. So just as before, we're going to split this up into half reactions. So it's going to be this manganese 4 oxide, and then the manganese oxide here. And then our second half reaction is going to be this, and then CO2. So let's write them out. Okay, so part 1 is done. Now 2A, balance all the elements except for hydrogen and oxygen. Well, here I only have manganese, which is already balanced. There's both one atom on each side. Here we have carbon. Now there's 2 on the left and 1 on the right, so I need to multiply the right by a coefficient of 2. So the next step, we need to balance the oxygens by adding water. Well, over here I have 4 and here I have 2. So what I need to do is add 2 water molecules on the product side. And then for the other half reaction, I have 4 here and 2 here. Sorry, this is actually 4. Multiply the coefficient, 2 times 2. So our oxygens are already balanced on that side. Next step is to add H plus ions to balance the hydrogen out. So I have 4 hydrogens here and none on the left. So I need to add 4H plus to balance out the hydrogens. On the other reaction, we don't have any hydrogen, so we'll skip that step. And then the next step is to balance the charges. So looking here, this side has a charge of 0. This is a +4 charge, and this is -1. So overall, I have a charge of 3 plus on the left side. So what I need to do is add 3 electrons to balance out the charge. So plus 3 electrons. And then our other side stays the same. For our other half reaction, we have a 2 minus here, and then 0 over here. So all we're going to do is add a 2 electrons here to balance it out, so they're both 2 minus charge. Okay, our next step is to multiply these electrons so that they cancel each other out. So we have a 3 and a 2, so we know that the least common multiple is a 6. So I need to multiply this equation by 2 and this equation by 3. So 2MnO4 minus plus 8H plus 6 electrons, 2MnO2 plus 4H2O. And then for this one, 3C2O4, 2 minus 6CO2 plus 6 electrons. And then once we have those balanced, we can add our 2 equations together. So these electrons are going to cancel out, and that's about it. So now we'll just add it all together. And that step might be a little messy, so I think I'm going to highlight everything just to make it more clear. So the reactants are all on the reactant side and the products are all on the product side. So if this were in an acid solution, we would be done now, but it's in a basic solution. So we need to move on to step 5, which says we need to add OH to both sides to neutralize the H+. So if we're looking here, we have AH+. So this means we need to add 8 hydroxides onto both sides. So I'm going to write this part over here. So you can see that when we add 8 hydroxide ions to 8 hydrogen ions, they're going to make 8 water molecules. And then on this side, we can keep everything the same. And then plus the AOH that we had before. And then our final step is to eliminate the water molecules formed. So because we formed 8 molecules of water here and we have 4 on this side, we can just eliminate this 4 and then change this to a coefficient of 4. So our final reaction is going to be 4H2O and then 2MnO2. This is completely gone, and then 6O2 plus 8OH. And then that's our final equation. Now you can do step 6 on your own, just count the atoms and the charges. So we have 2 manganese atoms, so that's done. The oxygens, we have 8 over here, 4 here, and 12 over here. Here we have 4, 12, and 8, so those all add up correctly. Here we have 8 hydrogens, and also 8 hydrogens here, because the coefficient. Here we have 6 carbons, and oh sorry, I think I forgot a C here. This should be CO2. Yeah, because this goes down here, I just forgot to write the C. So 6 carbons, here we also have 6 carbons. And now let's look at charges. So here we have 2 minus, 0, 6 minus, because of the coefficient. This is 0, 0, and then 8 minus. So then when we add these together, 2 minus plus 6 minus is going to be 8 minus, which equals a charge over here. And that's our final equation done. So hopefully that all makes sense. I'm going to scroll back here so you can look at the steps once again. And thank you for watching. Hopefully all those questions make sense.